Science is the pursuit of knowledge, understanding the world we live in to improve our human condition. Today, understanding the Earth's climate is essential to our prosperity. If climate changes significantly, it could impact our ability to grow crops, and shifting weather patterns could also mean dramatic changes to our water supply. But what if we could prepare for those changes? What if we could predict our climate's future by learning about its past? Year after year, our planet records its climate, freezing information into layers of Antarctic ice. And at Waste Divide, a site on the West Antarctic ice sheet selected for its pristine record of climatic changes, scientists are deciphering that information. To do so, they compare greenhouse gas concentrations from the past to temperature data, allowing them to predict how our climate will change in the future based on today's emissions. The wall of a snow pit helps to explain how this process begins. It snows about 2 feet at Waste Divide each year, and it's so cold there that the snow never melts. As it accumulates, the layers compress one another, and eventually the weight of layer upon layer compacts the older snow so much that it becomes solid ice. During this transformation, pockets of air between the snow crystals become trapped as tiny bubbles. A mile or two below the surface of this ice sheet, we find air bubbles that were trapped tens of thousands of years ago, and those bubbles contain samples of the ancient atmosphere. To collect them, scientists use a sophisticated coring drill.
This is the cutter head of our deep ice sheet coring drill. Notice it has 4 razor-sharp cutters on it, and these carve out ice cores buried deep in the ice sheet beneath us.
We send the drill more than 3,000 meters into the ice sheet, and every time we winch it back to the surface, it contains a sample of ice older than the last. We detach the core barrel from the drill and push the samples out into our core handling room next door.
In order to preserve the ice, the core handling room is kept below -20 degrees Celsius. Science technicians record each core's length, temperature, and the date of extraction. And after carefully logging each core, they pack it for shipment to the National Ice Core Laboratory in Denver, Colorado. Waste Divide is an integral part of an extensive research program, but in February, camp begins to close down for the Antarctic winter. Soon, the sun will disappear for more than 3 months, and temperatures will drop below -60 degrees Celsius. The scientists of Waste Divide will return to their universities, where Antarctic ice cores await further analysis. The work done here is only the beginning.